October 22nd, 2025. The day everything changed. Google has achieved what experts said was impossible: verifiable quantum advantage. And this isn't just about faster computers. This is about breaking the very laws of physics that have defined reality for over 200 years. Google's new Willow quantum chip has done something no classical supercomputer could ever achieve. It solved a problem that would take every supercomputer on Earth longer than the age of the universe. But that's not the shocking part. What they did next changed everything we thought we knew about physics itself. Using Willow, Google's team peered into molecular structures in ways that were literally impossible before. They shattered the Carnot principle, a 200-year-old law of thermodynamics that sets hard limits on efficiency. Researchers in Germany proved that quantum systems can go beyond those limits. They've shown that the boundaries of physics as we know them don't hold true at the quantum level. For 2 centuries, everything, from engines to processors, has been built around those thermodynamic limits. And now, suddenly, those rules no longer apply. Nature just revealed she's been hiding capabilities far beyond what we imagined. Google's Willow chip performs 1 trillion measurements, more than all previous quantum computers combined. And it did it in weeks. This is the moment quantum computing becomes not just real, but world-changing. There's a clear 3-part pattern emerging. First, we've reached quantum error correction below threshold. That means these computers can fix their own mistakes faster than they make them. Think of a car that repairs itself while driving at 200 miles an hour. Second, quantum supremacy is now turning into real-world impact. Google's new quantum echoes algorithm has been used to map molecular structures that even advanced NMR spectroscopy can't handle. That changes everything for drug discovery, materials science, and biology. And third, the biggest shift of all, we're now breaking classical physics itself. Quantum engines are turning the strange property of entanglement into usable energy. Machines at the atomic scale that can convert not just heat, but quantum correlations into work. That's not a 10% gain in efficiency. It's a total rewrite of what's possible. 2025 will be remembered as the year quantum moved from theory to unstoppable momentum. Willow's single-qubit fidelity is 99.97% and 99.88% for entangling gates. In plain English, it makes only 1 mistake every 10,000 operations, while working faster than anything ever built. Here's where it gets even more extraordinary. The quantum echoes algorithm doesn't just calculate. It creates a quantum butterfly effect, disturbing 1 qubit, running time backwards, and observing how that ripple spreads across the entire system. This gives scientists a new kind of molecular ruler, allowing them to see between atoms that were previously invisible to measurement. This means we can now explore molecules too complex for classical computing, discovering new medicines, catalysts, and materials that were beyond reach until today. And it's not just Google. Universities around the world are proving that quantum engines can exceed Carnot efficiency, and that quantum computers can now be designed specifically for chemistry and biology. The timeline for practical quantum advantage just collapsed. From someday to now, every industry that depends on computation just had its limits erased. Pharmaceutical companies, material scientists, chemical manufacturers, all of them now have access to power that was impossible a year ago. Expect an explosion of new drugs, new alloys, and new catalysts. Google's roadmap is accelerating too. After achieving quantum supremacy in 2019 and error correction prototypes in 2023, Willow now demonstrates below-threshold correction in 2024. The next goal is the long-lived logical qubit, the point where quantum computers become reliable enough for continuous real-world operation. That could be just 18 to 36 months away. And the pattern is unmistakable. Each leap takes less time than the one before. It took 40 years to make stable qubits. It took 4 years to turn that into practical supremacy. The next jump will come even faster. When that happens, we'll see industries transformed overnight. Drug discovery will collapse from 15 years to 1 or 2. Personalized medicine will move from fantasy to reality. Materials science will create room-temperature superconductors, batteries with 10 times current energy density, and compounds that don't exist in nature. Finance, energy, and climate modeling will all become predictive instead of reactive. And then there's cryptography, the double-edged sword. Quantum computers will break current encryption, but also enable unbreakable quantum encryption. Governments and corporations are already racing to make their systems quantum-proof before time runs out. But the most profound link is between AI and quantum computing. AI is now being used to design better quantum systems. And soon, quantum computers will be used to train AI faster than ever before. That feedback loop is only beginning. Once quantum machine learning becomes practical, we'll see AI that can think in quantum terms, using superposition and entanglement as tools instead of limitations. Here's the timeline. 2025 is the year of verification, proven quantum advantage. 2026-2027 brings fault-tolerant quantum systems that can run for extended periods. By 2028, we'll see commercial quantum computing for specialized industries. By 2030, quantum classical hybrid systems will be as common as today's supercomputers. Companies investing in quantum expertise now will dominate their fields by the end of the decade. But there's a dark side. Quantum power in the wrong hands is dangerous. The same tools that can cure diseases could also design bioweapons. The same systems that optimize clean energy could break into every bank on the planet. This isn't paranoia, it's physics. So what do we do? If you lead a business, start building quantum literacy now. If you're a researcher, explore how your field could benefit from quantum tools. If you're a student, learn quantum computing. It's going to be as fundamental as coding. Quantum isn't coming. It's here. And it's going to reshape medicine, materials, and money. The truth is simple. The organizations moving now will define the next decade. Google is openly publishing their results. They want collaboration because they understand that the power of quantum lies in shared discovery. This is a rising tide, but only for those ready to ride it. The future belongs to those who can think in superposition, who see uncertainty as opportunity, and who understand that the rules of classical reality no longer apply. Quantum computing isn't just the next step. It's the foundation for everything that comes after: AI, energy, medicine, and materials. It's the engine of exponential progress. We're not ready, but it's happening anyway. You can either ride the wave or get swept away by it. Subscribe and stay ahead of the quantum revolution. Because what happens next will redefine what's possible for the human race.